Hi, this is Stephen Estelle, the Applications Engineer at RapidScan 3D, and I'm going to show you some tricks and tips on Geomagic Control-X. So what you're going to see right now is we are currently importing a scan data of an impeller as well as CAD model of the exact same impeller that was created to see how the deviation is between the two. And we're going to utilize this software to do an inspection. So right now we just use the scan data as a measured, and we're using the CAD data as the reference. So the first step is to do an initial alignment, and what this does is it lines up the two different datas very roughly and quickly just to get a general idea of how they're going to line up. However, in this example, the two arches on the rim of the circle of the impeller do not line up exactly how we want. So what we need to do is a transform alignment to make sure we rotate it to make sure that the two arches line up just about right to get in the position we want. After that, we do a best fit alignment, which does 100% best fit alignment and locks in to the best location so that we can do a proper inspection on the two different models. After that, we're going to do the 3D compare. And what the 3D compare does is that you can choose which kind of projection direction you want to do. We're going to normally just go with the shortest, but you can do different things such as along the normal of the surface. When you're in the 3D compare, you can do a color map, whiskers, or color point to display the deviations. Color map just covers the entire CAD model or the reference that you utilize, while whiskers creates lines, and a color point just makes it a bunch of dots that display the deviation of the different models. You can also change the max range. So for this example, I'm changing it to 2 millimeters. However, I'm just going to go back and leave it at 1. And you can set that to however you need it to be. You can also change the tolerance level. So by default is at 0.3 millimeters, but if you need to go in and change to a specific tolerance, you can do plus or minus 0.1 or whatever you need it to be. You can also go in and change the over tolerance count and the under tolerance count, so you can map out where exactly the max and the minimum tolerance count is located, and it points it out. The blue is the under tolerance in this one, and that orange is the over tolerance, and that is the max and min, orange being the max and blue being the min. So now we're doing a comparison point. So what a comparison point is, you're able to just select the location and get the information at that exact spot. So it shows the gap distance and the tolerance that you set of that spot that we clicked on. And from there, you can utilize it wherever or however you rotate the model. So there's two different ways you can display the information. You can have the models just free floating, or you can just have them set up so that no matter where you are, they're both spaced out equally. And on top of that, you can right click on each box, and you can also edit whatever you want to appear inside of that information box, such as the font or other results. So what we're going to do now is we're going to hide the data we just collected, and we're going to show you a 2D comparison. What we showed you before was 3D, but now we're just going to show you somewhat of a cross-section. So here's a cross-section about the y-axis of the two different CAD models, or two different data sets that we got. And here's a cross-section of a different axis. So for this example, we're just going to utilize the y-axis. And it pretty much gives you the same things. You could change the projection direction, you can change the different max ranges of the tolerance, as well as different tolerance counts and under and over tolerances as well. And as you can see, the color also represents where the tolerance lands. If it's blue, it's just about under tolerant, and if it's red, it's over, and if it's green, that means it is within your selected tolerance that you wanted. So now what you could also do is change the template to match what you're looking for. You can change the symmetry, the go or no go, as well as just signed. And what you can also do is you can change the coloration in there too. So let's say if you have a company that you want to match the colors with, you can change that to however you want. The one we're showing now is the discrete, which shows like a gradient of the color, and the other one's signed, which allows you to just change the color to a good or no, and you can change to whatever color you want on the color wheel. So I'm just going to reset it all and go back to the default settings that we had initially. So the next thing we're going to show you is that you can take a viewpoint of the model that you just did your results on. So this could be advantageous for your report that's going to be generated at the end, as well as if you want to save a viewpoint, you can do that so that you can snap to that viewpoint whenever you need to. So currently we are taking snapshots of different positions of the impellers, and you can take as many as you want and you can include them all into your report. So as you can see in the bottom left of the screen, you can see the viewpoint when you select it, and then you can click apply viewpoint so that your mouse snaps to that exact model viewpoint that you want. We're going to rename them all as the position that is. So the first one's going to be top view, the next one is a bottom view, and the very last one we're going to set as the side view of the impeller. So these custom views can be very beneficial if you have a very complex item and you want to make sure that the specific area is demonstrated in your report, and you want to make sure that it gets attention that it needs. So now we're just going to go ahead and click generate report, and this happens really quickly. So the first thing you want to do is select which entities you want to include in your report. So for this example, we're going to take out the initial alignment as well as the transform alignment, just because we're just mainly focused on the best fit alignment, which shows the two impellers lined up perfectly over each other. From there, you want to fill in the information at the bottom, the field name and the field values. So we're just going to go ahead and title this Impeller Inspection. We're just going to name the subject Impeller. We're going to leave the author as Rapid Scan 3D. Some keywords that I believe are important are Impeller, which is the model that we're working on, Control X, we're going to put down water pump, since the impeller was most likely utilized for some form of water pump or water system, as well as tolerance. We're going to make a comment, and we're going to say that the impeller was scanned, and then we're comparing it to a CAD model. So we're filling out these field names and field values so that when the report is generated, if you are delivering this report to somebody else who has no idea what they're receiving or looking at, this information can fill them in on exactly all the details. So for this example, we're going to do the product name as a water pump system. The part name is just going to be impeller. Part number is going to be number 1. And then for the department, we'll just do water. And then for an inspector, I'm going to put down my name, Stephen Estelle. And then once you have all your information filled, you hit generate, and then it gives you a preview of what the report looks like. So now that you have a preview of the report, you want to just look through it very briefly to make sure you have all the information there. It shows the units that you were working on. It shows all the information you typed in. That's the reference data. It shows the front, top, and right view. It also gives the file name as well as the measurement and the units for that one. It shows the measure data. That's the scan file. It shows your best fit alignment. It shows the min and max deviation and the averages. And that's the two models stacked on top of each other. It shows a 3D compare. We'll do a 3D comparison of the two. It shows you the max and min of all the different tolerances. It shows those specific points that we're comparing when we're selecting certain areas, and it shows you their gap distance and tolerances. This is our two-dimensional comparison between the two models. Then it shows us our different snapshots that we took. So that's the top view that we had. Here's the bottom view picture that we took. And then here's the side view picture. So everything looks like it is in order. If you needed to, you could go ahead and change the font. You could change anything. But if everything looks good, you hit the PDF button in the top left ribbon. You change your file name. So we're going to make our file called report for Impeller. Make sure we want to save it as a PDF. And you hit save. And then it opens it up. And this is how you generate your report for Geomagic Control-X. The report comes out very clean. Everything looks nice and really, really clear. The pictures are nice. You're able to see all the details just as if they came or they're actually being viewed in the software. Nothing is blurred out and everything is very clearly represented just as it was in Geomagic Control-X. So that's the end of the video. This is Steven Estelle, the Applications Engineer at RapidScan 3D. If you have any further questions, feel free to contact us. And thank you for watching.